Cross-cutting concepts serve as a bridge to connect the disciplinary core ideas of science: life, earth and space, and physical science. They create a common thread from the beginning of the school year to the end, and across years of science instruction. Most importantly, cross-cutting concepts represent the major themes by which modern scientists consider content, providing access to a deeper understanding of the world around us. There are 7 cross-cutting concepts, as described in the NRC framework and Next Generation Science Standards. 1. Patterns. 2. Cause and effect. 3. Scale, proportion, and quantity. 4. Systems and system models. 5. Energy and matter. 6. Structure and function. And 7. Stability and change. Cross-cutting concepts come to life during class discussions. As students are engaged with sense-making discussions, explicit instructional strategies using cross-cutting concepts can help students learn how to extract meaning from data. Here, kindergartners are sharing their direct observations of snail structures and functions.
Who wants to share what they said or what their partner said about the parts of the land snail's body?
I have the tentacles.
The tentacles. Did you notice how many there were? How many did you observe?
4.
Did they all look the same? They all look the same? Do you guys agree? Did you guys also see tentacles?
The tentacles are not tentacles. They're actually eyes.
How do you know?
Because I did not see the eyes, so it must be on the tentacles.
You think the eyes are on the tentacles? Do you think they have 4 eyes? Or do you think there were eyes on some of the tentacles?
There's not a lot. There's only 2.
You think there are 2 eyes?
The shell and their back.
The shell was on the land snail's back. What's the shell for?
The shell is for their back, so they could be safe.
So up here it says land snail. And I drew my best picture of a land snail. And we're going to find the different parts and put the words up there so we know how to write those words. So we were just talking about this part. Can you say what it's called?
Shell.
Shell. And the shell is to keep the snail safe and protected. So we put, can you read it? Shell. And you guys were talking a lot about those. Who remembers what they're called? Can we all say it? Tentacles. That is a long word, right? And you guys made an important observation that there was something on the end of those tentacles. What was it? Eyes. These are the parts of the snail's body that I didn't hear you talking about as much, and maybe you don't know the name for. Raise your hand if you know the name of this long part right here.
They're like sticky.
It felt sticky to you guys, right?
Yeah.
It's called mucus, right? So the snail has on that big part of their body a lot of mucus. And we're going to observe today why they have it. But this part is kind of funny because do you have feet?
No.
You don't have feet?
Yeah.
How many do you have? 2. Me too. But this snail just has 1, and it's most of their body. That's called the snail's foot.
Teachers can use a series of questions during a sense-making discussion to guide students to use a specific cross-cutting concept. As you watch this 4th grade class, pay attention to how the questions support students' thinking about cause and effect relationships.
The tortoise digs deep to get away from the heat.
What is the cause of the tortoise digging? Why is it digging? Heat. And heat is an example of a
Non-living thing.
A non-living factor. Yes, so the cause is the heat. The effect is, does anybody remember what that's called when organisms dig to escape the heat? Do you know what the word is? Burrows, yeah. So let's write the scientific word here, burrows. So yeah, animals burrow in the desert to get away from the heat. Because it's so hot, what do the animals do? They burrow. All right, so I'm gonna give you another effect. And this time, I want you to think about what is the cause?
Here, students are asked to explain the cause of an observed effect.
Desert plants spread their roots. What is the cause of them needing to spread their roots? Think.
I think that's to reach water, because in the already, on the tag, it says that I think it reaches 81 milliliters to reach water. I think that it's rainfall because there isn't really that much rain in the desert. And I guess and they have to spread it to get enough space, and it's like they're competing to get as much water as possible so they can keep on growing.
In the Investigations Guide, you will find embedded strategies for cross-cutting concepts. Visit the Cross-Cutting Concepts chapter for your grade level to learn more about additional strategies you can add into your science instruction.